Today's lesson is going to cover a review of the three sections and the three topics we've done with solving systems of equations. So remember, when you solve a system of equations, your solution can be one of three things. We can have intersecting lines where they have exactly one solution, which would be the ordered pair where they intersect. We can have parallel lines or no solutions, and we could also have the same line or infinitely many solutions. Today we're going to review graphing, solving by elimination, and by substitution. So the first example is graphing. And we're going to graph y equals 2x plus 1, and we're going to graph y equals 3x minus 1 to find where the two lines intersect. So I'm going to do the first line in red. When graphing y equals 2x plus 1, I start up at positive 1. My slope is positive 2 or 2 over 1, so I'm going up 2 over 1 to the right, and I'm going to go down 2 and over 1 to the left. My next equation I'll just do in a different color. You don't have to, but we've got y equals 3x minus 1. So we're going to start down at negative 1, and I'm going to go up 3 over 1. And remember, we want to continue that pattern in both directions. Oops, I think I just went down 2 there. And then we can see where these two lines intersect. I'm going to darken that point here. And when we solve by graphing, we then just write that answer as an ordered pair. So these two lines intersect at 2, 5. 2, 5 is the solution to the system. Next, we learn how to solve by substitution. When we solve by substitution, remember, we want to solve one equation for one of the variables and then substitute the resulting expression into the other equation. So you can see in this problem, we've already got the first equation solved for y. So we're going to circle that, and we're going to plug it in for y in the second equation. So writing the second equation with the substitution, we have 3x plus 3 times the quantity of negative x plus 2, and that equals 12. Now we have an equation with one variable, and when we solve this equation, you can see that the variable is going to eliminate. 3x minus 3x is 0, so we're left with the statement 6 equals 12. This is not true, so these would be parallel lines when we graph them because it has no solution. These two lines, when graphed, would never intersect. Finally, we solved by elimination. We solved by elimination, we're trying to get opposite coefficients in front of the variable. So in the first equation, I have 2x plus 3y equals 8. If I multiply the second equation by a negative 3, then I'll be able to eliminate the y's. So we have negative 9x minus 3y equals negative 15. Now when we solve 2x minus 9x, or 2x and negative 9x, is going to be negative 7x, and 8 plus negative 15 is negative 7. Dividing both sides by negative 7 gives us that x equals 1. We're going to take that x value and plug it into either the first or the second equation. You're going to substitute it in for x so that we can solve for y. Here we get y equals 2. So the solution to this system is 1, 2. Again, that's where the two lines intersect. I will check your notes in class and we will work on the review worksheet 6.1 to 6.3.